Hello again, and thank you for taking the time to join us today. My name is Ian Goodrich from Spire Global, and I'm really glad you took the time and look forward to sharing this content with you. We have a full agenda today, and I'm really excited to share the speakers. From the Spire Global side, I'm joined by 3 colleagues, and from the Freightwaves side, we're joined by 2 experts. Everyone will take a few minutes to introduce themselves as we move through the presentation. So this is a brief agenda of what we're going to cover today. One of the really nice things about today is we're also going to be doing a live demo. And then Freightwaves will also be running through their company overview and talking a little bit about what they're planning to use ADS-B data for. Okay, first up, I wanted to spend a few minutes giving everybody a quick understanding of what Spire Global is. For those of you who didn't know a little bit about us, we're actually a satellite company. We own and maintain and build our own constellation of satellites. We have 84 satellites in orbit today, and each of those are currently equipped to perform certain tasks. One of them being collecting ADS-B data from space. The satellites are also able to collect AIS messages for vessel tracking and RO profiles for weather forecasting data collection. We're actually going to be spending a little bit of time today talking about our aviation weather product and how that is fused with our ADS-B position reporting as well. One of the things we pride ourselves on, though, is how we take that data from space and make it really easy to consume and work with. Even though the whole process is quite complicated between collecting the data in space, downloading it, processing it, we deliver it to you, customers, using very, very simple APIs. Okay, so rather than spending a lot of time just talking about Spire, I'm actually going to move into the ADS-B presentation, and I'm going to ask my colleague Teresa to take over the presentation here, and she's going to cover our global ADS-B product. So Teresa, I'm sending you over the presentation.
Thanks, Ian. Hi, this is Teresa Revelli, and I am the product manager for aviation at Spire. I want to spend some time today talking about, well, why do we have an ADS-B product? Our product exists because of the GAD's mandate, 4015 mandate to track flights. After the Air France disaster in 2009 and then the missing Malaysia airliner in 2016, it spurred the industry to come together to create the Global Aeronautics Distress and Safety System. The 4015 mandate was created. The 4015 mandate essentially says that an operator obtains 4-dimensional aircraft position information, meaning specifically latitude, longitude, altitude, and a timestamp at 15-minute intervals or less. And this is the aim of our product, AirSafe. Okay, the AirSafe product contains data from ADS-B transmissions from aircraft that are where the ADS-B messages are downloaded from the satellites, decoded, and fused into an update for each aircraft. We offer 2 different delivery mechanisms for the same data. We offer a push API stream, and we also offer a pull or a polling API for retrospective searches in our database. The AirSafe data combines both the terrestrial and space-based data. We have more than 80 million updates daily. This varies with the number of flights that there are on any given day. These updates include the latitude, longitude, altitude, and time for more than 99% of the updates they are delivered in under that 15-minute window. We have the same data schema across both of our products. It doesn't matter what your delivery format is, you're getting the same field names, you're getting the same data schemas to make it easier to use one or the other product. Spire is keenly aware that we do not yet have full global satellite coverage for the data deserts, the oceans, the mountains, and the underserved parts of the world. In 2020, we're targeting the plus or minus 15 degrees of the equator to improve our coverage. We have 8 satellites that are launching in Q1 and another 8 satellites in Q2. We are adding 5 new ground stations to Spire's proprietary network of ground stations, and that should bring us over 37 satellite ground stations in total. And in 2021, we are launching inter-satellite links to further improve our data latency, and additional satellite launches in 2021 will complete the global coverage. We have a nice visualization here of where the equator lies on a map, so that you just have a nice visualization. So it'll be plus or minus 15 degrees of the equator. So you can see that this will really benefit areas that are today underserved. So everything from the oceans between Australia and Asia to South America, Central America, as well as Africa. Lastly, I want to talk about where we're going with the product. We currently offer flight schedule data that's available with positional updates. We will be adding a separate feed for flight schedules in order to give the information in advance. This is directly in response to customer feedback. And then we're also, we already offer Spire's Aviation Weather Global Forecast, but we want to integrate that even more fully into our products. So we will be offering clear turbulence, winds aloft, icing at every 1,000 feet of vertical resolution. So with that, I'm going to pass it over to Asma.
Hi everyone, I'm Asma Torman and I'm the product manager for weather forecast at Spire. So as we all know, extreme weather events are becoming more and more frequent. And in the meantime, there is no real improvement or innovation in the weather industry. Weather forecast quality is stagnating year after year, and the quality overall is pretty much the same year after year. Spire is now setting a new benchmark in the weather industry. How do we do that? We do that by collecting atmospheric weather data from across the planet to create global weather forecast. Spire is continuously launching new satellites month after month, and we are projected to have more than 100 nanosatellites by the end of 2020. What is radio occultation? Radio occultation technology is a very powerful technology. So Spire sensors are catching the signals from GPS satellites. Those signals pass through a portion of the atmosphere, causing them to bend. And by comparing how these frequencies are bending, Spire learns about the temperature, the pressure, and the humidity of the atmosphere, and feeds that into its weather models. What are the main advantages of radio occultation? Radio occultation provides a vertical scan of the atmosphere, covering the entire globe, and collecting atmospheric density data from ground up to 120 kilometers. If we compare that with satellite images, they only provide a picture of the atmosphere horizontally and only on one spot. The second main advantage is the fact that it provides a true global coverage. We're collecting data continuously all over the globe with no blind spots. So what is the added value overall? It provides a true global coverage with no blind spot, providing better observation in remote areas. It provides a highly accurate measurement of temperature, and most importantly, a better understanding of the atmospheric condition globally, creating highly valuable weather forecast. Now, how do we integrate this technology into our models? So we use a combination of multiple data sources, NOAA, ECMWF, satellite images, and observations. And we add on top of that a unique source of data, which is radio occultation data. And only Spire has access to this data. So this process allows us to enhance our initial global weather condition. Then we process this data into more detailed weather variables, and we're able to provide the weather forecast via an easy API-friendly solution. So Radio occultation technology allows Spire to continuously improve weather forecast accuracy. And as we launch more and more satellites through them every month. So now if we go a little bit more in details into the weather product that we have for the aviation industry, we provide 3 types of product. The first one provides an airport level understanding of the weather conditions with air temperature, relative humidity, and wind speed and direction, for example. The second package is an in-flight weather package, which offers wind speed and direction, clear air turbulence, and potential for aircraft icing. And the third package is a thunderstorm package, a little bit more specific. We provide this data globally and on a short and medium range forecast, and of course, via easy to use API. Now I'll pass over to Will to provide you a more detailed demonstration and live demonstration of our product.
Hello, everyone. Will Fernandez, VP Global Aviation for Spire. And thank you, everyone, for joining today. I want to thank Ian, Asma, Teresa, and Fabio, our product managers, and everybody who works on our systems here at Spire Global. The ability to use this information and the ability to see ADS-B through our APIs has now gone to new levels. So what everyone is looking at, hopefully right now, is the global ADS-B for the entire world. Currently, our ADS-B APIs are providing all of this information to users around the world for tracking of aircraft, flight optimization, the ability of tracking their own specific airlines through the GADS mandate. But this is what you see when you start looking at our data, and you can see it refreshing every 5 seconds. And the nice thing about our data is the combination of weather information that you are able to conflate with it to really study what's going on in the atmosphere or what's going on with your flights. So looking at ADS-B, we have the ability now of providing not only global ADS-B packages of all the aircraft flying around the world, but we can also look at specific aircraft. So using the ICAO address of a specific fleet, you're able to look at aircraft. We're able to also use call sign and tail number to look at those aircraft. So on call sign, it's very easy to do. It's just a matter of clicking in a few numbers, and what comes up is ability to see a specific aircraft. So you can see a Hungarian airline here flying off the coast of Africa, and we provide a tremendous amount of information associated with that aircraft. As you can see, ICAO address, call sign, flight number, but we also know where this aircraft is going. So it's origination airport, destination airport, and the schedule. And what's beautiful about this system is that now we can also provide the ETA of the specific aircraft as it's flying on its route. So in this case, we're seeing that the airplane will be 10 minutes early in arrival to its destination airport. We can also look at, let me get rid of him. We can also look for tail numbers. So if it's a business jet, private aircraft, or an airline. So if you're working in Part 91, 135, or 121, we can take a look for those aircraft by their tail numbers. So in this case, I'm going to use a US airline. And now you can see this aircraft here just leaving out of, I believe it was Oakland. Yeah, leaving Oakland out of Las Vegas. And he is still not taking off. He's not doing anything. He's doing 0 ground speed. And so that brings up an important part. We're able to see when the aircraft is on the ground or in the air. So setting that ground flag is a product feature that will be coming up. We also hope to have UI information, so off blocks, off gate, on on gate and in coming as part of the product, which we're really excited about. However, and all of this is available through our APIs currently today, and ongoing product innovation through our ADSB APIs will be part of any package that a customer should sign up for. So there will be no upgrades that you'll have to pay for or options. So that's a nice benefit of providing this the APIs from Spire to your company, is because of the fact that you're able to take all the innovation we have today and tomorrow into your visualization tools or your data, or however you may be using the API information. I'm going to go ahead and move into the weather piece here. I'm going to turn these aircraft off and talk a little bit about weather. So what you're looking at currently today is the weather or winds aloft at 35,000 feet with an output that we provide every hour to airlines, to ASPs, whoever may be using this weather data, or whoever is very interested in looking at our weather data to support flight operations, airport operations, to support logistics operations. You can now have a global view of the entire world of weather from one source for aviation. Let's run through a little functions here. So what we're looking at here is an altitude scale bar that allows us to pick any altitude from 10,000 feet to 45,000 feet, which is usually the ability to track aircraft in their flight levels on a specific flight. And I'll stop that. The other ability that you saw from Asma's presentation was the ability to have all the different individual needs from your meteorologist served from one application as well. Our API is now providing out the entire source of functionality a meteorologist would need as part of this, part of your meteorology staff. We are also providing a lot of interesting information, such as absolute vorticity. We can see that as well. And okay, so we'll go back here a little bit and provide a little refresh here to see if I can pull up absolute vorticity now. There you go. So this is the absolute vorticity of the atmosphere currently today. We can also run all of these single level or isobaric level functionality with an output of every hour as well. But what we're really here for is to look at the winds, icing, and clear air turbulence. So again, with the scale bar, it allows you to pick the destination of or direction of your aircraft. So if we were flying from San Francisco to Heathrow Airport today, we'd be flight level 35,000 across the United States and on to England. And you can see the wind patterns throughout the entire flight. We can also do an hourly output of that as well. The icing levels, what you'll see here in the icing levels, that we automatically change the icing level down to the specific altitudes where we do find it. So here at 14,000 feet, you can see that we have icing through the west coast of the United States and approaching into Texas all the way to Dallas at 14,000 feet. And we can bring that all the way down to the surface if need be as well. So depending on your flight needs or operation needs, you have that flexibility with our APIs. The other unique thing that only a satellite can bring and our staff in Boulder, Colorado can bring is the clear air turbulence functionality. So last year, just to give you a use case here, last year in 2018, the US had over 1,000 flight crews out of work for more than 3 days. The cost of workman's comp associated with that crew being hurt due to turbulence or clear air turbulence last year was $36 million. And when you look at turbulence and the cost of turbulence around the world, what happens is that the aircraft get damaged in those turbulent events as well. And so last year alone in 2018, over $499 million of aircraft damage was charged to the airlines and for their operations just because of turbulence alone. So we really feel that having the ability to see this clear air turbulence globally from one vendor not only will be a benefit to the passengers and to the airlines, but it'll be a huge safety benefit for any airline operation. I'm going to go back to winds here. And you can see winds across the United States, across the Atlantic, and going into Europe. One of the neat things that we are now being able to do is being able to provide flight details associated with the weather. So if I was flying to here to Cincinnati, where Ian is, and then off to Scotland, this is a great circle route that most any flight planning system provide. What you'll see happen in the lower section here is ability to have the vertical cross section of that flight plan laid out to you at every 1,000 feet along that flight plan. So this is very interesting for anybody who is doing any type of flight planning or trying to estimate when an aircraft will arrive. So you can see here along my flight path, we provide a lot of variable information for you to look at. And if you can look on my flight path along the white line, you'll see a blue cursor, and that blue cursor will move along the vertical cross section as I move along. So you can see right here at 36,000 feet, we would be having an 85 knot tailwind. So you have to remember on a 777 or 787, every 10 knots of tailwind given to an aircraft saves over 500 pounds of fuel an hour. So could you imagine being able to provide that level of accuracy in your winds of law forecast for the pilots? And the beauty is this visualization tool, not only can you do the great circle routes for flight planning, but we can also then add your AirRink 424 actual flight plan information into it as well. So you can get very specific observations and forecasts for your flight. So in this case, I'm sitting here at 36,000 feet and I would have an 85 knot tailwind. So being able to say, oh, that's great, I want an 85 knot tailwind for my flight plan. We bring another level of complexity to your flight planning activities. We can now overlay clear air turbulence associated with that 85 knot tailwind. So you can see the system calculating on the bottom right-hand side there. And what will happen is you can now start looking, well, that 85 knot tailwind, oh, here's a 100 knot tailwind at 37,000 feet. Perfect. And the associated turbulence, as you can see there, for clear air turbulence is 0.012, which is light turbulence for aircraft over 150,000 pounds. But as you can see, as we move along the flight plan, when we get into this high wind area here, you can start seeing the tailwinds go up over 100 knots. However, as soon as you penetrate deeper into this wind event here, you can see that the turbulence goes up as well. But you can see it's almost come down here a little bit. So that's severe turbulence right there at 39,000 feet. You'd want to avoid that. So imagine being able to confidently forecast clear air turbulence and provide the best tailwinds possible for any flight flying around the world from one source. So our APIs are now giving such great information that a lot of people are coming to us and saying, hey, can you help us figure this out and add your APIs to our existing systems? And the answer is yes. So with this technology, we can not only give you ADS-B, but we can also give you weather and be able to conflate the two to see where your aircraft are going to fly through and where they are now and see the events they're going through. And since this system can be used as is, we can provide the ability to access these hourly forecasts through the browser that may be as part of an EFB in the cockpit that's being updated through SATCOM. So it's a very exciting time for Spire Global to provide these APIs out, and that's all I have for today. And I'm going to pass this over to Ian.
Thanks, Will, for that great demonstration. That was very insightful. Okay, so now I have the pleasure of adding our two featured guests from Freightwaves today to the webinar. I'm going to go ahead and reshare the presentation here for everybody. And I'm going to ask Jesse from Freightwaves to jump on the line.
Oh, good morning and good afternoon, everybody. As Ian noted, my name is Jesse Cohen. I'm the air cargo market expert at Freightwaves. I spent 30 years in the airline industry on the cargo side of the business. Most of my time was spent at United Airlines, but I also worked for 2 other foreign flag carriers. So Freightwaves is a 2-year-old technology-based startup that is headquartered in downtown Chattanooga. We are fast growing. We're now at 160 employees, either in Chattanooga, but many of our employees are working remotely throughout the USA, Canada, Europe, and Australia. Our aim is to be the leading provider of market intelligence to the global freight industry. We believe we've achieved that already in the 2 years. We also tell folks we want to be the Bloomberg of freight. Our customers and folks that we work with include trucking companies, brokers, shippers, freight forwarders, airlines, and investment advisors. So right now, we are really a software as a service business. That's really our core focus. We have a data platform called Sonar, which houses huge volumes of near real-time freight transportation information. It has maps, it has charts, it has tables, etc., now covering all modes. The transportation industry has historically lacked a lot of real-time data. What we've been able to do at Freightwaves has been able to bring a lot more transparency to real-time data, particularly on the full truckload side of the business, but also on some of the other modes. So the other part of our business is we have a very active freight transportation news website, www.freightwaves.com. And also AmericanShipper.com that kind of co-link together. So Freightwaves.com is the largest publisher of global service transportation in the world, and it's powered by Sonar data that's real-time and that's behind it. And then American Shipper has a lot of global trade flow information and a lot of information for multimodal shippers, a lot of information on the ocean freight side and air freight as well. We use the Sonar to help drive content into our website and to provide a lot more analysis and data backup that other websites just simply don't have. So basically, we started 2 years ago, focused largely on the trucking industry, and we built out our coverage and our analytic capabilities to air, to rail, to ocean. We're improving our barge, river transportation coverage, and even drones. So we're very pleased to say that we've achieved over the last 2 years sharp growth in terms of being where folks are turning to for their news on freight. We have 2.8 million page views a month. We're really besting a lot of the legacy publications in trucking, transport, and logistics. And these are some of the accolades that we've been receiving from venture capital firms, as well as the freight technology industry. And now I'll turn it over to my colleague, Justin Childress.
Thanks, Jesse. Hey, everybody. My name is Justin Childress. I work as a data scientist with Freightwaves. I'm here to talk briefly about how we're using Spire ADSB data right now and how we're planning to take that in the future. Last month, we launched Sonar 5.0, which was the big update, which is a major update to Sonar. Part of Sonar includes this powerful map application which lets you get down to the market level and look at conditions, look at market level conditions for that. One of the key features that Sonar 5.0 brought to the table was this vehicle tracking information. You can see a screenshot right now of our aircraft maps, which is being powered by Spire's data. A lot of this is similar to the demo that Will was showing you. It's just a bit more streamlined for our customers' purposes and needs. This kind of thing is letting us see how many planes are in the air at a given time, how many are moving from one location to another. We know where the plane is, how many are going, who's flying it, and through knowing what the aircraft type is, we can make really strong estimates as to how much freight capacity that plane actually had at the time. This next slide is a screenshot of the vessel data. It's the same kind of thing, but for ships. That's also being provided by Spire, but it's a different product of theirs. This next slide is an overview of what we're planning, where we're planning to go with Spire, what we're trying to do with it in the future. A lot of it can be done in isolation just within the Spire data set itself. But part of what's really exciting is that we're going to be able to tie that into and strengthen a lot of our existing air cargo data sets. We're trying, of course, to always have the most updated and accurate data possible. But sometimes that means that we don't know. Sometimes that means that our data is 6 months old because that's as soon as anybody can get it. But if we know how many tons moved from one place to another 6 months ago, and through Spire, we know how many planes were in the air at that time, then since we know how many planes were in the air yesterday, we can start to forecast that forward and come up with really good estimates and start aligning all of our data sets so that even if we're forecasting it, our lags start to decrease by a lot. Within Spire itself, we're going to be able to start looking into which airports do the best job with handling delays or avoiding them altogether. If there are any companies that stand out specifically, we're able to recognize when aircraft start to enter a holding pattern, which is obviously wasted fuel, wasted time. We can start doing research into are weather events causing these holding patterns, are aircraft policies or overbooking or something causing inefficiencies that we can recognize and start to track. We're also able to verify schedules. If we know we have the schedules and we know 12 weeks from now what planes are supposed to be in the air. We know what planes were supposed to be in the air today from 12 weeks ago. We can look at Spire's data in real time and see how well people are adhering to those schedules. That's going to be a crucial component when we want to start taking those other data sources and start forecasting them into the future. If nobody else knows how many tons moved from one spot to another over the last 3 months, and we're able to provide through Spire's data how much of that is we expect to happen in 6 months or 3 months, however far in advance that ends up allowing us to go, that's going to be amazing. Spire is a really exciting data source that's going to help us a lot with capturing the nuances of air cargo. As Freightwaves continues to expand our scope into global trade and global freight movements, then being able to reliably track every single commercial plane, that's going to be a really powerful tool and a growing arsenal that we're developing of logistics data. Thank you, guys.
Thank you, Justin. That was great. But I wanted to thank all of our speakers today and thank you for attending. And like I said, this presentation will be sent for you to share with your colleagues. And I hope everybody has a great day. Thanks so much.